You know, every single second of the day, your body is performing this incredible, totally invisible balancing act just to keep you alive. And no, I'm not talking about walking a tightrope. It's something way more precise, and it's happening inside every single drop of your blood. So let's dive into this little masterclass of biological engineering.
Okay, see this number? This is basically the magic number for human life. Well, all right, technically it's a super tiny range from about 7.35 to 7.45. But 7.40, that is the absolute sweet spot. It's the perfect pH for your blood, not too acidic, not too alkaline. It's the just right that allows everything to work.
And when I say delicate, I really mean it. If that number drifts just a little bit in either direction, the enzymes that run your cells start to freak out, your organs get stressed, your whole system can just go haywire. So the stakes for this constant moment by moment adjustment are incredibly high. And that right there is the big question for us today. I mean, if this balance is so critical, what systems are actually in place to manage it? Who are the guardians of that perfect 7.40 pH? Well, it turns out your body has this elite emergency response team on call 24/7. So here's our game plan. We're going to meet this team. First, we'll talk about the tightrope itself. Then, we'll meet the fast-acting first responders, your lungs. After that, we'll get to know the long-term strategists, your kidneys. We'll see how they work together as a team. And finally, why this whole balancing act is pretty much the foundation of your health. All right, let's set the stage. Because to really get the solution, you've got to appreciate the problem. How do we keep the concentration of hydrogen ions perfectly stable in all our body fluids? At its core, it really is all about these little guys, free hydrogen ions, or H+. So, to put it simply, an acid is anything that releases these H+ ions, making things more acidic. And a base? That's anything that can grab onto those free H+ ions, pulling them out of the solution and making it more alkaline. And the key to this whole balancing act is this one brilliant chemical reaction right here, the bicarbonate buffer system. Just think of it as the body's chemical middleman. See, on the left, you've got carbon dioxide, CO2, and on the right, you have bicarbonate, HCO3-. The most important thing to see here is that two major organs are in charge of managing the two ends of this equation, all to control that H+ right in the middle. First up, let's meet the fast responders. This is the system that can jump into action in a matter of minutes to fix a problem. Yep, we're talking about your respiratory system. The main idea here is actually really simple. Just think of your lungs as your body's acid manager. And why? Because they control the amount of carbon dioxide. And as we just saw in that equation, CO2 turns into acid super easily once it's in your blood. And the genius of this whole system is just how fast and simple it is. Your brainstem is constantly checking your blood's pH. If it senses things are getting too acidic, it sends an immediate signal. Breathe faster, breathe deeper. By blowing off more CO2, you are literally blowing acid out of your body. It's a physical, mechanical solution that works in minutes. So this brings us right back to our main equation. See, by controlling the CO2 on the far left, the lungs can immediately change the amount of H+ in the middle, pushing that balance right back toward that perfect 7.40. It's just an elegant and incredibly rapid response. But, a fast response isn't always a permanent fix. For that, we need the body's long-term strategists, and that would be your renal system, your kidneys. They might be slower, but man, are they powerful. So, if the lungs manage the acid side of things, the kidneys are the absolute masters of the base side. Their main tool is bicarbonate, that HCO3-. They have this amazing, fine-tuned ability to either reabsorb this base back into your blood or just get rid of it in your urine. So why are they so much slower? Well, it's because this isn't just a simple mechanical change like breathing. The kidneys are doing something way more deliberate. Inside millions of these tiny filters, they have to perform really complex cellular transport, literally deciding molecule by molecule which base to save and which acid to dump. This is high-level chemical engineering. It's not a simple reflex, and that's why it takes hours or even days to really see the full effect. And this shows us their exact role in our little buffer system. The kidneys directly control the bicarbonate on the far right. So by increasing or decreasing the amount of this base in the body, they can provide a powerful, long-lasting correction to your blood's pH. And this, right here, is what makes them the ultimate long-term strategists. See, the kidneys don't just manage base.
they manage the entire fluid environment of your body by controlling salt balance, water levels, even your blood pressure. This total command over your body's internal sea is what gives them the profound power to make these lasting adjustments to your pH. They're not just tweaking the chemistry, they're managing the entire ecosystem. So, what we have is a fast responder and a long-term strategist. And the thing is, neither one of them works in isolation. Their real effectiveness comes from how they cooperate as this perfectly integrated team. And here we can see them side by side. You've got the lungs providing that fast mechanical fix by changing how you breathe, and then you've got the kidneys providing the slow, powerful chemical solution. It's really the perfect partnership between a quick fix and a permanent one. And check out this timeline of defense. Instantly, within seconds, the chemical buffers right there in your blood absorb the first shock. Then, within minutes, your lungs kick in, adjusting your breathing. And finally, over hours to days, your kidneys get to work to provide the definitive, lasting correction. It's just a beautiful, multi-layered defense system. So, the biggest thing to take away is this. You've got two totally distinct but perfectly complementary systems. One is for rapid, temporary adjustments, and the other is for slow, powerful, permanent fixes. Together, they keep that tightrope walker perfectly balanced. So what happens when this elegant system gets pushed to its absolute limits? This is where we see just how critical that balance truly is. Let's take a look at a real-world clinical example. And this is the bottom line. It's not just some abstract number on a chart. This balance dictates how every single part of your body functions. A small shift can have massive ripple effects. Okay, let's look at the case of Diane, who has something called diabetic ketoacidosis. First, her pH is 7.25. That's dangerously low, which means her blood is way too acidic. Now look at the cause. Her bicarbonate, the base, is extremely low. That's the metabolic problem. But here's the amazing part. Look at her CO2, the acid. It's also low. So why would that be? It's because her lungs have gone into overdrive, making her breathe super fast to blow off as much acid as they possibly can to compensate. This chart just beautifully shows the lungs, our fast responders, desperately trying to fix a problem that was created somewhere else in the body. It's a system in crisis, for sure, but it's also a system working exactly as it's designed to. You know, the lungs and the kidneys, working in perfect harmony, they perform this balancing act countless times a day, and we are completely unaware of it. It's this silent, essential dance of chemistry and physiology, and it really makes you wonder, what other invisible, incredible systems are hard at work right now, in this very moment, just keeping you alive?